Imagine this, it's the middle of the day. Not late enough to be tired in any dramatic sense, but something feels off. Your thoughts don't flow the way they did in the morning. You read the same sentence twice. You open something, then forget why you opened it. Nothing is seriously wrong, yet everything feels slightly out of place, like a musical instrument that has drifted just a little out of tune. Most people would say, "You need rest." That sounds simple. Almost too simple. Because what does rest actually mean for a brain? When we say the brain is resting, we tend to imagine something like a machine being switched off. No movement, no activity, just a pause. But that picture is deeply misleading. The brain is not the kind of machine that turns off. Even when you are asleep, it is active, sometimes in ways that are even more structured and intense than when you are awake. So if a nap isn't about shutting the brain down, then what exactly is happening? To get closer to the answer, it helps to replace the idea of a machine with something more alive and complex. Think of your brain as a busy city. During the day, this city is flooded with activity. Signals are moving in every direction. Decisions are being made constantly. Sensory information is pouring in: light, sound, touch, internal thoughts, memories. It's like rush hour that never quite ends. Cars honking, people crossing streets, deliveries being made, construction happening in the background. Now imagine trying to repair that city while everything is still moving at full speed. You want to fix a traffic light, but cars are still rushing through the intersection. You want to clean the streets, but people keep dropping more things. You want to reorganize a building, but it's still full of occupants moving around. It's not impossible, but it's inefficient, messy, and incomplete. A short nap changes one crucial variable: the level of traffic. When you begin to fall asleep, your brain does not shut down the city. Instead, it reduces the flow. Fewer cars are moving. Fewer external signals are demanding attention. The constant interruptions begin to fade. This creates a very unusual condition. Not silence, but space. And in that space, different kinds of processes become possible. Maintenance doesn't require total shutdown. It requires enough quiet for small adjustments to take place without interference. Signals can be recalibrated. Activity can become more coordinated. Patterns that were previously buried under noise can begin to emerge more clearly. So the idea of rest is not entirely wrong, but it's incomplete. It suggests passivity when in fact something active is happening. A better way to think about it is not that the brain stops working, but that it changes the mode in which it works. Instead of reacting to the outside world, it begins to reorganize itself internally. And that shift from outward engagement to inward adjustment is subtle enough that we rarely notice it happening, yet powerful enough that after just 20 minutes, the same brain can return to the same world and experience it differently, not because the world changed, but because the internal traffic did. Now let's move a little deeper into what actually begins to happen in those first minutes after you close your eyes. At first, nothing dramatic occurs. There is no sharp boundary where wakefulness suddenly ends and sleep begins. Instead, the brain drifts. It slides gradually, almost reluctantly, from one state into another. If you could observe it closely, you wouldn't see a switch flipping. You would see patterns slowly reshaping themselves. In the waking state, brain activity is fast, irregular, and highly responsive. Different regions are firing in ways that reflect everything you are doing: seeing, hearing, thinking, reacting. It's a bit like a crowded room where everyone is speaking at once, forming small clusters of conversation that constantly change. As you begin to fall asleep, that pattern starts to shift. The first noticeable change is a reduction in how strongly your brain responds to the outside world. Sounds are still there. Light still reaches your eyes. But the brain begins to treat these signals differently. It's as if incoming information is no longer urgent. The system stops prioritizing every small detail. Imagine you're sitting in a room with a ticking clock. When you are fully alert, you hear every tick. But as you get drowsy, the ticking fades, not because the sound disappears, but because your brain stops giving it importance. This is the beginning of what could be called a partial disconnection, not a full shutdown. More like loosening the grip on reality. At the same time, something else is happening internally. The chaotic firing patterns of neurons begin to organize into slower, more rhythmic activity. Instead of scattered bursts, groups of neurons start firing together in coordinated waves. This change is subtle but important. When activity is scattered, it carries a lot of information, but it also carries noise. When activity becomes synchronized, the overall system becomes more stable. It's similar to the difference between a crowd shouting randomly and a group clapping in unison. The second case doesn't necessarily contain more information, but it has structure. Structure allows the brain to operate more efficiently. During this early stage of sleep, the brain is not trying to solve new problems or take in new information. Instead, it begins a kind of internal housekeeping. Signals that were overlapping and interfering with each other during wakefulness can now be separated and adjusted. There is also evidence that the brain starts lightly processing recent experiences, not in a deep, permanent way that requires longer sleep, but in a preliminary sense. It's as if the brain is asking, what from the past few hours might be worth keeping? You can think of it like emptying your pockets at the end of the day. You don't immediately organize everything into perfect categories. You just take things out, look at them briefly, and decide what might matter later. This stage of a short nap does something similar. Fragments of thoughts, bits of memory, unfinished impressions, they begin to settle. Not fully sorted, not permanently stored, but no longer completely tangled. And all of this happens without your awareness. From the inside, it feels like nothing. Maybe a few drifting thoughts, maybe brief images that don't quite make sense. But beneath that quiet surface, the system is shifting from a reactive mode to a more organized one. By the time those 20 minutes are over, the brain hasn't transformed into something new. It hasn't gained new knowledge or erased old problems, but it has changed its internal arrangement just enough that when you return to wakefulness, the same thoughts can move more smoothly, the same perceptions can feel clearer, and the same mental effort can produce slightly better results. A small shift in pattern, yet a noticeable shift in experience. There is another layer to this process that is less about patterns of activity and more about chemistry. Something you cannot feel directly, yet it quietly shapes your sense of fatigue throughout the day. As you remain awake, your brain is constantly using energy. Every thought, every perception, every small decision requires neurons to fire, signals to travel, and resources to be consumed. This ongoing activity produces byproducts, and one of the most important of these is a molecule called adenosine. Adenosine builds up gradually while you are awake. Not in a dramatic way, but steadily, almost like dust collecting on a surface you rarely notice. At first, it doesn't seem to matter. But as the hours pass, its presence begins to influence how your brain operates. It does not force you to sleep in a direct sense. Instead, it changes how responsive your brain feels. It creates a kind of pressure, a subtle resistance to continued activity. Thoughts feel heavier. Focus requires more effort. The same task that felt easy in the morning begins to feel slightly strained. You can think of adenosine as a signal that reflects how long the system has been running without pause. Now here is where things become interesting. A short nap, around 20 minutes, does not remove all of this buildup. That would require much longer periods of sleep. The brain does not suddenly become chemically clean again. Yet, something still shifts. It appears that even a brief period of light sleep changes how the brain responds to the presence of adenosine, not by eliminating it completely, but by adjusting sensitivity to it. It is as if the brain recalibrates its interpretation of that chemical signal. Imagine wearing a heavy backpack for hours. Over time, it feels increasingly burdensome. Now imagine setting it down briefly. Not long enough to unpack everything inside, but long enough that your muscles relax and your posture resets. When you pick it up again, the weight hasn't changed, but your experience of carrying it has. A short nap seems to create a similar effect. The chemical signal associated with fatigue is still there, but the brain is no longer reacting to it in quite the same way. The sense of pressure is reduced, not erased, but softened. There is also another subtle point here. During wakefulness, the continuous stream of activity keeps reinforcing the effects of adenosine. The brain is both producing the signal and responding to it at the same time. When you nap, that loop is interrupted. Activity slows, input decreases, and the system briefly steps out of that cycle. Even this short interruption can be enough to shift the balance. This helps explain something that might otherwise seem puzzling. Why such a short period, too short to fully restore the body, can still produce a noticeable change in alertness. It is not a full reset. It is more like adjusting the system so that it can function more effectively with the resources it already has. Of course, there are limits. If the buildup of adenosine is too high, if you are severely sleep deprived, a 20-minute nap may not be enough to overcome that pressure. The system may briefly improve, but the underlying imbalance remains. This is why sometimes a short nap feels refreshing, and other times it barely makes a difference. The effect depends on the state of the system before the nap begins. And this brings us to a broader realization. What you experience as tiredness is not just a simple lack of energy. It is the result of chemical signals, neural activity, and system-level responses interacting in complex ways. A nap does not solve all of these factors, but it nudges them, just enough to change how the same brain continues forward. There is something surprisingly delicate about the length of a nap. It might seem like more sleep should always be better, but that intuition turns out to be unreliable. The difference between 5 minutes, 20 minutes, and an hour is not just a matter of degree, it is a matter of entering entirely different states. If you lie down for only a few minutes, your brain often doesn't fully transition out of its waking patterns. You may feel slightly relaxed, but the deeper reorganization never really begins. It's like slowing down a machine without actually changing how it operates. The surface becomes calmer, but the internal structure remains largely the same. On the other hand, if you sleep for too long, something else happens. Your brain continues moving through its natural sleep cycle and begins entering deeper stages. These stages are not just more sleep. They involve fundamentally different patterns of activity. Neurons fire in slower, more powerful waves. Large regions of the brain synchronize in ways that are very different from the lighter stages. This deeper state is useful, even necessary, for other functions, such as more thorough memory consolidation and physical restoration. But it comes with a cost if interrupted at the wrong moment. Waking up from deep sleep is like being pulled out of a dense fog. The system is not ready to switch modes instantly. The organized, slow patterns of deep sleep do not immediately translate back into the flexible, fast patterns required for wakefulness. So for a period of time you experience what is often called sleep inertia. A kind of mental heaviness where thinking feels slow, reactions are delayed, and clarity is reduced. It's not that something has gone wrong. It's simply that the brain is in between states again, but now in the opposite direction, trying to climb back up into wakefulness instead of drifting down into sleep. This is why a longer nap can sometimes leave you feeling worse than before. A 20-minute nap sits in a narrow and somewhat fortunate window. It is long enough for the brain to disengage from constant external input and begin organizing its internal activity. But it is short enough to avoid crossing deeply into those slower, heavier stages that are harder to exit quickly. You might think of it as stopping a process at just the right moment, after useful changes have begun, but before the system commits to a deeper transformation. Timing in this case is everything. There is also variability here. Not every brain follows exactly the same schedule. Factors like how tired you are, what time of day it is, and even your individual biology can shift how quickly you move through these stages. For one person, 20 minutes may stay entirely within light sleep. For another, it might brush the edge of something deeper. This variability explains why naps are not always predictable. Sometimes you wake up feeling clear and refreshed. Other times, even after a short rest, there is a lingering sense of grogginess. The boundary between light and deep sleep is not a sharp line. It is more like a gradual slope. And where you happen to wake up along that slope matters. What makes the 20-minute range effective is not that it guarantees a perfect outcome, but that it increases the probability of stopping in that lighter, more easily reversible state. So the usefulness of a nap is not just about sleeping, it is about where in the process you choose to return. And that choice, whether deliberate or accidental, shapes how the brain re-enters the world it never fully left. To understand a short nap more clearly, it helps to step away from biology for a moment and imagine something more familiar. Picture a large library at the end of a busy day. All morning and afternoon, people have been coming in and out. Books have been taken off shelves, flipped through, stacked in corners, left open on tables. New materials have arrived and been dropped onto carts. Some books are carefully placed, others are scattered in small, messy piles. At first glance, nothing is fundamentally wrong. The library still functions. You can still find things if you try hard enough. But movement becomes slower. Paths between shelves are slightly blocked. Finding a specific book takes longer than it should. Now imagine that the library closes, but only for 20 minutes. This is not enough time to fully reorganize everything. No one is going to reshelve every book or rebuild the entire catalog system. That kind of deep, thorough work requires hours. But something meaningful can still happen in a short closure. The staff can walk through the space and make quick decisions. Obvious clutter can be cleared. Books that are completely out of place can be grouped into rough categories. Tables can be straightened. Walkways can be opened again. No new books are added. No major renovations occur. But the structure becomes easier to navigate. When the doors reopen, the library is still the same library. The same books exist. The same information is present. Yet your experience of using it changes. You move more smoothly. You find what you need with less effort. The system feels more cooperative. This is a useful way to think about what happens during a short nap. Throughout the day, your brain accumulates fragments of experience, conversations, images, problems, half-formed ideas. These do not arrive in neat categories. They overlap, interfere, and compete for attention. While you are awake, the brain is busy handling incoming information. It has limited opportunity to step back and organize what has already been collected. So things begin to pile up, not in a chaotic disaster, but in a way that gradually reduces efficiency. A 20-minute nap creates a brief pause in that constant inflow. It is not a complete shutdown, just a temporary closing of the doors. During that time, the brain can begin small acts of organization. Signals that were interfering with each other can be separated. Patterns that were unclear can become slightly more defined. Some information may be marked as less important and quietly fade in priority. This process is not deliberate in the way conscious thought is deliberate. There is no inner voice deciding what to keep or discard. Instead, it is an automatic reshaping of activity, guided by patterns, connections, and prior significance. And importantly, it is incomplete. Just like the library staff cannot finish their work in 20 minutes, the brain does not fully resolve everything. Deep sorting, long-term storage, and more complex restructuring require longer periods of sleep, but even partial organization has value, because disorder does not need to be eliminated to become manageable. It only needs to be reduced. When you wake up from a short nap, you are not returning with new knowledge or solutions that appeared out of nowhere. You are returning to the same mental landscape, but one that has been slightly rearranged. Bots are clearer. Interference is lower. Access is easier. And that small shift is often enough to make thinking feel smoother. Not because the system has changed dramatically, but because it has been quietly adjusted in ways that reduce friction. A brief closing of the library, just long enough to make it usable again. There is a point where explanations begin to thin out, not because nothing is happening, but because our ability to describe what is happening starts to fall behind. We can measure electrical activity in the brain with impressive precision. We can detect changes in frequency, observe shifts in synchronization, and map which regions become more or less active during a short nap. We can track chemicals like adenosine and correlate their levels with feelings of fatigue. We can even test behavior, reaction time, memory recall, attention, and see clear improvements after brief sleep. But there is a gap between measuring a system and truly understanding it. We can say that neurons become more synchronized, but that does not fully explain why this leads to clearer thinking afterward. We can observe that sensory input is reduced, but that does not tell us exactly how the brain decides what to ignore and what to keep processing. We can describe patterns, but the meaning of those patterns, the way they produce experience, remains partly hidden. This becomes especially noticeable when we try to answer a seemingly simple question. Why does a 20-minute nap feel the way it does? Not just the physical refreshment, but the qualitative shift, the sense that thoughts are easier to access, that the mind feels less cluttered. We can point to contributing factors, but no single mechanism fully accounts for that experience. Part of the difficulty lies in the nature of the brain itself. It is not a single process, but many processes interacting at once. Electrical signals, chemical gradients, structural connections, and dynamic patterns all overlap. When you change one aspect, it influences others in ways that are not always predictable or linear. So when a short nap alters brain activity, it is not producing a single effect. It is nudging a complex system, and the result emerges from the interaction of many small changes. Another challenge is that the brain is both the system being studied and the tool used to study it. Every explanation you form about how your mind works is itself generated by that same mind. This creates a kind of loop that is difficult to step outside of. It is like trying to understand the structure of a maze while you are still inside it. You can gather clues. You can map sections. But seeing the entire layout at once is not straightforward. There are also individual differences that complicate the picture. Some people benefit greatly from short naps, while others notice little change. Some feel refreshed, others feel disoriented. Even for the same person, the outcome can vary from day to day. This suggests that the underlying mechanisms are sensitive to initial conditions, the exact state of the brain before the nap begins. Small differences in fatigue, stress, timing, or prior activity can shift how the system responds. And then there is the deeper question that remains unresolved. What exactly is the relationship between these physical processes and the experience of thinking itself? We can observe correlations between brain states and mental clarity, but explaining how one becomes the other is still an open problem. How does synchronized neural activity translate into the feeling of a clear thought? How does reduced noise become the experience of focus? These are not just technical questions. They point to limits in our current understanding of the mind. So when we talk about what happens during a 20-minute nap, we are describing pieces of a larger puzzle. The measurements are real. The effects are observable. The patterns are consistent. But the full picture, the complete explanation that connects physical processes to lived experience, is still incomplete. And recognizing that incompleteness is not a weakness, it is a more honest description of where we stand. There is something particularly strange about the state a short nap occupies. It does not fit neatly into the categories we usually rely on. You are not fully awake, but you are not deeply asleep either. It is a kind of in-between condition, and the brain behaves differently in such boundary regions. When you are fully awake, your brain is highly responsive. It is constantly predicting, reacting, adjusting. Incoming sensory information is prioritized, interpreted, and integrated into a continuous model of the world. Time feels stable. Cause and effect seem clear. Your sense of self feels anchored. In deep sleep, many of these features change dramatically. External input is largely ignored. Internal activity becomes slower and more synchronized. The sense of a continuous, structured world fades. In some stages, even the sense of self becomes fragmented or disappears entirely. But in a short nap, especially one limited to light sleep, you hover between these two modes. And this is where things become interesting. At this boundary, the brain is not committed to a single way of operating. It is loosening its grip on external reality, but it has not fully replaced that with the internally driven patterns seen in deeper sleep. As a result, both influences are present, but neither is dominant. You might notice this as drifting thoughts that don't quite follow logic, images that appear briefly and dissolve, sounds that blend with imagined fragments. Time may feel slightly distorted, longer or shorter than it actually is. You are still connected to the world, but the connection is weaker, less stable. This instability is not a flaw. It is a feature of transitional systems. In many areas of science, the most interesting behavior occurs not in stable states, but at the edges between them. Consider the boundary between solid and liquid, where materials can behave unpredictably, or the edge of chaos in dynamic systems, where patterns form and dissolve in complex ways. The brain during a short nap exists in a similar kind of transitional regime. Its usual constraints are relaxed. Patterns that would normally be suppressed during focused wakefulness can briefly emerge. Associations may become more fluid. Rigid structures loosen just enough to allow subtle reconfiguration. This may help explain why, after a nap, problems sometimes feel easier to approach. It is not necessarily that the brain solved anything during those minutes, but that it stepped out of its usual rigid patterns and returned with slightly more flexible organization. At the same time, this boundary state is fragile. If you are pulled out of it too abruptly, or if the brain has already begun transitioning into deeper sleep, the return to wakefulness can feel disorienting. The system needs time to stabilize again, to reestablish the fast, coordinated activity required for clear thinking. This is why the timing of a nap matters so much. It is not just about how long you sleep, but about where you are within this shifting landscape when you wake up. What makes this difficult to describe is that boundaries do not have sharp edges. There is no precise moment where you can say, "Now I am asleep," or "Now I am awake." Instead, there is a gradual blending, a continuous shift in which different processes rise and fall in influence. And because we tend to think in categories, this continuous change is hard to capture in simple language. But the reality is that much of the brain's behavior exists in these gradients. A 20-minute nap is not a single state. It is a passage through a region, a narrow zone where the system is neither fully engaged with the world nor fully withdrawn from it, and where small internal adjustments can take place before the structure settles again. That in-between space, brief and often unnoticed, plays a quiet but meaningful role in how the mind resets itself. One of the main reasons this whole process is difficult to explain is not a lack of data, but a limitation in how we tend to think. We prefer clean categories. We like to divide things into clear states: awake or asleep, working or resting, active or inactive. These distinctions are useful in everyday language, but they begin to break down when we look closely at how the brain actually behaves. The brain does not switch between neat boxes. It moves along continuous ranges. At any given moment, different parts of the brain can be in slightly different states. Some regions may still be processing external information, while others have already reduced their activity and shifted inward. Even within a single region, patterns of activity can vary. Some neurons firing rapidly, others slowing down, some becoming synchronized while others remain irregular. So when we say you are awake or you are asleep, we are compressing a very complex, layered process into a simple label. A short nap exposes the limits of those labels. During those 20 minutes, the brain does not fully leave wakefulness behind, nor does it fully enter deeper sleep. Instead, it occupies a range of intermediate configurations. These configurations are not fixed points. They are constantly shifting, moment by moment, as the balance between internal and external processing changes. This makes explanation difficult, because language tends to describe stable things more easily than changing ones. It is much simpler to explain a system that is either on or off than one that is continuously adjusting itself across many dimensions at once. There is also another layer to this difficulty. We experience the result, but not the process. From the inside, you do not perceive neurons synchronizing or sensory signals being deprioritized. You do not feel adenosine levels rising or falling. What you experience instead is a change in clarity, a shift in how easy it is to think or focus. This creates a gap between objective description and subjective experience, Science can describe the measurable changes, the patterns, the signals, the correlations, but translating those into the language of lived experience is not straightforward. The feeling of mental freshness after a nap does not correspond to a single measurable variable. It is an emergent result, built from many small changes interacting together. Another complication is that the brain is adaptive. It does not respond to the same conditions in exactly the same way every time. Its behavior depends on context. How much you slept the night before, what you have been doing during the day, your stress levels, even your expectations. This means there is no single, fixed explanation that applies perfectly in all situations. Instead, there are patterns and tendencies, probabilities rather than certainties. This kind of explanation can feel unsatisfying because it lacks the precision we often expect. We want clear rules. Do this, and that will happen. But with complex systems like the brain, outcomes emerge from interactions, not simple cause and effect chains. And then there is a deeper issue. The brain is trying to understand itself. Every concept we use, every model we build, every explanation we construct is generated by the very system we are attempting to explain. This creates an inherent limitation. It is not impossible to make progress. Clearly we have, but there may always be aspects that remain difficult to fully capture. It is similar to trying to see your own eyes without a mirror. You can infer their existence, study their structure indirectly, even build detailed models. But direct access is limited. So when we struggle to explain something as seemingly simple as the effect of a 20-minute nap, it is not because the phenomenon is trivial. It is because it sits at the intersection of many processes, physical, chemical, and experiential, all interacting in ways that resist simple description. What appears simple on the surface, closing your eyes for a short time and waking up clearer, is underneath a continuously shifting system that does not fit neatly into the categories we prefer to use. And that mismatch between simplicity of experience and complexity of mechanism is exactly what makes it so hard to fully explain. If you put all of this together, a different picture begins to form, one that is less about rest and more about subtle reorganization. During a short nap, nothing dramatic is added to your mind. You do not acquire new knowledge in any obvious sense. You do not suddenly become more intelligent. And yet, when you wake up, something feels different. The same thoughts are there, but they move more easily. The same problems exist, but they seem slightly less tangled. The same environment surrounds you, but it appears a bit clearer, more manageable. This is a strange effect if you think about it carefully, because the external world has not changed at all. What has changed is the internal arrangement of the system that perceives and interprets that world. Throughout the day, your brain is continuously processing information, responding to stimuli, and generating thoughts. This constant activity leads to a kind of internal buildup, not just in a chemical sense, but in the organization of signals. Patterns overlap. Some become reinforced, others interfere with each other. The system remains functional, but it gradually accumulates friction. A short nap reduces that friction, not by removing everything, but by adjusting how things are arranged. It is similar to slightly untangling a set of wires. You have not replaced the wires or changed their purpose, but by reducing the crossings and knots, the entire system becomes easier to work with. This small internal shift has a noticeable consequence. Your experience of reality changes. Clarity is not an inherent property of the world itself. It is a property of how effectively your brain can process and interpret incoming information. When the system is disorganized or overloaded, the world feels confusing, even if nothing external is particularly complex. When the system is more organized, the same world can feel simple. This suggests something that is easy to overlook. What you perceive is not just determined by what is out there, but by the current state of the mechanism doing the perceiving. A 20-minute nap highlights this in a very direct way. Before the nap, you may struggle with a task, feel mentally heavy, or find it difficult to focus. After the nap, the task has not changed, but your ability to engage with it has. The difference lies entirely within the system. This raises a deeper question about how we interpret our own experiences. When something feels difficult, we often assume the difficulty belongs to the task or the situation. But part of that difficulty may come from the internal condition of the brain at that moment. Its level of organization, its responsiveness, its current balance of activity. A short nap does not solve external problems. It does not alter the structure of the world, but it can change the internal conditions under which those problems are approached. And that change can be enough to make the difference between confusion and clarity. There is something quietly profound in that. It suggests that understanding is not just about gathering more information, but also about the state in which that information is processed. In other words, the quality of thought depends not only on what you think about, but on how your brain is configured while thinking. A 20-minute nap is one of the simplest ways this becomes visible. A small adjustment, barely noticeable in itself, yet capable of shifting the entire way the same reality is experienced.